Humanity has spent thousands of years searching for the fountain of youth. We have looked for it in alchemy, in mythology, and now in technology. We are terrified of aging. We fear the day our muscles weaken, our bones become brittle, and our cells stop renewing. But while we spend billions of dollars trying to stop the clock, there is a creature crawling in the mud of the ocean floor that seems to have already solved the puzzle. It isn't a mystical being. It's a lobster. Yes, the same creature you see on a dinner plate with a side of melted butter. But biologically, the lobster is a freak of nature. Most animals follow a predictable curve. You are born, you grow, you reach a peak, you age senescence, and you die. The lobster ignores this curve. Instead of getting weaker as they age, lobsters get stronger. They don't lose fertility. An old lobster actually produces more eggs than a young one. Their metabolism doesn't slow down. In theory, if you protected a lobster from predators, disease, and starvation, it simply wouldn't die of old age. It exhibits what scientists call negligible senescence. This has led to a popular myth on the internet. Lobsters are immortal. It sounds incredible. An animal that could theoretically live forever. But if that's true, why aren't the oceans filled with lobsters the size of school buses? Why don't we see 1,000-year-old leviathans ruling the Atlantic? The answer is tragic. The lobster has hacked the code of aging, but it forgot to check the laws of physics. It has fallen into an evolutionary trap. The very mechanism that makes them immortal is also the thing that eventually kills them. They don't die because they run out of time. They die because they run out of energy. In this video, we are going to look at the biology of the creature that forgot to die. We will examine the enzyme that keeps them young, the brutal physics of their shell, and the sad story of George, the 140-year-old giant. To understand why true immortality is mathematically impossible, to understand why lobsters are special, we first have to understand why we are not. Why do humans age? At a cellular level, aging is basically a copying error. Every time your cells divide to make new cells, they have to copy your DNA. But the copying machine isn't perfect. At the ends of your chromosomes, there are protective caps called telomeres. Think of telomeres like the plastic tips of glaze at the end of a shoelace. They keep the DNA from fraying. However, every time a human cell divides, a tiny piece of that telomere gets chopped off. Over decades, the telomeres get shorter and shorter. Eventually, the plastic tip is gone. The shoelace frays. The DNA gets damaged. The cell stops dividing and becomes senescent zombie-like, or dies. This is the Hayflick limit. This is why your skin wrinkles and your organs fail. But the lobster has a cheat code. It possesses an enzyme called telomerase. This enzyme is a biological repair crew. Its job is to rebuild the telomeres. Now, humans have this enzyme too, but we mostly turn it off after we are born, except in stem cells and dangerously in cancer cells. Lobsters, on the other hand, keep the telomerase factory running full-time in almost all of their adult tissues. This means that every time a lobster cell divides, the telomerase rushes in and adds the missing cap back onto the DNA. The result? Perfect replication. A lobster's DNA at age 50 looks almost identical to its DNA at age 5. Its cells literally do not know how old they are. This allows the lobster to bypass the degradation that plagues mammals. Its muscles don't atrophy. Its appetite doesn't fade. In fact, biologically speaking, a 50-year-old lobster is physiologically just a bigger version of a 5-year-old lobster. This ability is the holy grail of modern medicine. Scientists are studying lobsters to see if we can harness telomerase to treat human aging or diseases like progeria, but there is a catch. In humans, if we activated telomerase everywhere, our cells would divide uncontrollably. That's called cancer. Lobsters somehow manage to keep this unlimited growth in check without turning into giant tumors. Their immune system is incredibly robust. So, on paper, the lobster has won the lottery. Infinite cell renewal, infinite growth. But nature always collects its debt. The lobster has solved the problem of time, but it is about to run headfirst into the problem of space. Here is the curse of the lobster. To live is to grow. To grow is to molt. Lobsters are arthropods. They live inside a rigid exoskeletonous suit of armor made of chitin and calcium. This armor does not expand. Imagine if you were wearing a suit of steel armor that was welded shut. As you ate and gained weight, the armor would start to crush you. The only way to survive is to break out of the armor and build a bigger one. This process is called molting or ecdysis. For a young lobster, molting is easy. It happens frequently, maybe 10 times in the first year. They slip out of the shell, pump themselves up with water to stretch the new soft skin and harden up. But as the lobster gets older and bigger, the laws of physics start to turn against it. We have to talk about the square cube law. As the lobster grows larger, its volume and mass increases much faster than its surface area. A 20-pound lobster is not just twice as hard to molt as a 10-pound lobster. It is exponentially harder. The shell becomes thicker. The shell becomes heavier. To molt, a giant lobster has to reabsorb calcium from its old shell to weaken it. It has to essentially dehydrate its muscles to shrink them down just enough to squeeze through the narrow opening of the carapace. It is a violent, traumatic, and exhausting physical ordeal. Imagine trying to squeeze your entire body through the neck of a t-shirt that is 3 sizes too small, while holding your breath. This requires energy, massive amounts of metabolic energy, and the bigger the lobster gets, the more energy it needs to push off that heavy shell. But remember, the lobster never stops growing. So, the gap between molts gets longer. A giant lobster might go 2 or 3 years between molts. During this time, the old shell starts to degrade. It gets dirty. Barnacles and bacteria start to grow on it. This leads to shell disease. Bacteria eat away at the armor, fusing the old shell to the flesh underneath. Eventually, the lobster reaches a metabolic tipping point. It is now too big. Its shell is too heavy. It prepares to molt. It tries to push. It burns every calorie in its body. But it's not enough. The energy required to break the shell exceeds the energy the lobster possesses. The lobster essentially gets stuck. It dies of exhaustion. Or the shell cracks halfway, leaving the animal vulnerable to infection and collapse. Or, sensing that it cannot molt, the lobster simply stops trying. The shell rots. The immune system is overwhelmed and it dies. So the lobster doesn't die of old age. It dies of size. It is a victim of its own success. Its cellular immortality forces it to grow until it becomes a prisoner of its own physics. To see this paradox in real life, we have to talk about George. In 2008, a seafood restaurant in New York City, City Crab and Seafood, had a mascot sitting in its tank. He was a monstrous American lobster named George. He weighed 20 pounds, 9 kilograms. Most lobsters you eat are about 1.5 pounds. George was a titan, but how old was he? Since lobsters don't have birth certificates, scientists use a rough formula involving weight and water temperature. They estimated George's age to be roughly 140 years old. That means George was born around 1869, shortly after the American Civil War ended. He was swimming in the ocean before the light bulb was invented, before the car, before the internet. George became a celebrity. PETA and other animal rights groups campaigned for his release. Eventually, the restaurant agreed. George was driven to Maine and released back into the wild. But George's story highlights the physical limit we discussed. At 140 years old, George was likely near the absolute edge of what is physically possible for an exoskeleton. Why haven't we found a 200-year-old 50-pound lobster? Because of engineering? If a lobster continued to grow to 50 or 100 pounds, its shell would need to be incredibly thick to support its own weight and protect it from crushing pressure. A shell that thick would be practically impossible to shed. Furthermore, the gills, which are part of the exoskeleton, have to be shed too. A massive body needs massive oxygen. If the gill surface area doesn't keep up with the body volume square cube law again, the giant lobster would suffocate. So, while George's cells were still young and producing telomerase, his structural engineering was failing. He wasn't dying of biological age. He was dying of architectural obsolescence. Also, we cannot ignore the other factor: predators. The biggest predator of lobsters isn't time. It's us. Codfish and sharks eat the babies. Humans eat the adults. For a lobster to reach 140 years old, it has to be incredibly lucky. It has to avoid every trap, every net, and every predator for a century and a half. In the wild, statistical probability kills you long before biology does. The story of the immortal. Lobster teaches us a humbling lesson about nature. Biology is powerful. It can invent enzymes like telomeres that can literally repair the fabric of life and stop the clock. But physics is absolute. You can cheat death, but you cannot cheat thermodynamics. You cannot cheat gravity. Everything has a cost. For the lobster, the cost of eternal youth is eternal growth. And eternal growth is sustainable only in a universe with infinite energy and zero resistance, which is not the universe we live in. The lobster is caught in an infinite loop: grow or die. And eventually, the grow part becomes impossible, so die is the only option left. It forces us to wonder about our own quest for immortality. If we could use gene editing to turn on telomeres in humans, would we solve death? Or would we just trade one set of problems for another? Would we run out of resources? Would our brains run out of storage capacity? Would we succumb to diseases we haven't even discovered yet? Perhaps the lobster is a warning. Immortality is not a state of being. It is a trap. True endlessness doesn't exist in the physical world. Every system, no matter how perfect, eventually hits a wall. So the next time you see a lobster, don't just see a meal. See a biological marvel that fought a 100-year war against entropy, only to be defeated by its own armor? What do you think? If you could have the lobster's power of eternal youth, but you had to grow 10% larger every year, would you take the deal? Let me know in the comments below. If you enjoyed this deep dive into the biology of the deep, smash that like button, break out of your shell, and do it. And subscribe to Beyond the Apex. Stay curious, stay evolving, and I'll see you in the next video.